Hello my dear students, we are starting the next module, the second module, that is engineering properties of rocks used as construction material. In the first module we have learned about the introduction of engineering geology into the civil engineering as well as in mining engineering. Now after studying this module you shall be able to know different uses of rocks in construction industry. You will be able to learn about physical and mechanical properties of rocks to be used in different construction purposes. You will be able to understand different aspects of site or foundation rocks, and you will be identify different rock mass properties which are controlling behavior of rock mass in case of loading as well as unloading. In construction industry, rocks are being used as construction material and as a founding ground. When we are using rock as a construction material, then we refer it to the rock material, which is being brought from some other different places. Well, when we use rock as a founding ground or as a site rock, then we use the term rock mass, which refers to in situ rocks encompassing all discontinuities and alteration induced by weathering. If you go for different uses, then you can have uses of rocks as aesthetic material, where we use rocks for the stone carvings, for the statue making, for beautification of buildings. We use building stones for making columns, walls, flooring, roofing, and cladding of buildings, as well as pavement of slabs. We use rocks in much bigger size when we use them as a part of fort walls, bridges, retaining walls, lighthouses, abutments, dams, seawall, jetties and dikes. There we call these rocks to be dimension stones. We use rock as an important part of concrete as an aggregate. We use rocks for making a road in different parts of our road as a sub-base course, wearing course of road. We also use rocks for providing cushion and base to the railway tracks. We call them rail ballast. We use rocks as an energy dissipator along shores, river bends, waterfronts, spillway definitions, etc. Now, when we talk of rock mass, where we are going to use rock at its original place by founding some structure over them or by making some structure inside them, then we call them to be the founding rock or site rocks. We have different physical, mechanical and chemical properties termed as geotechnical properties, which broadly depends upon physical appearance, strength and stability of the constituent minerals, how they have been interlocked with each other within a rock, presence of layers in terms of bedding, foliation and fractures. Once we have all these, we test their geotechnical properties in terms of its strength, in terms of its resistance to abrasion, in terms of its inertness, in terms of softness for different uses. Now, any material which is natural, geological, man-made or otherwise can be used in construction industry. This material must satisfy two fundamental properties, that is strength and economy. The strength of rocks comes from its texture and mineral composition, and weakness creep in due to alteration caused by weathering and deformation. Rocks which are taken from near the earth's surface, they may be somewhat weak because they have been affected by weathering, and the rocks which are taken from deeper parts, they may be fresh and strong. Because rocks are not engineered materials, hence their properties can show extreme variation from place to place. Now, economy, when we use rocks, we should try to get these rocks from the nearby sites so that the cost should not get high while hauling them from the source place. So, cost is always a very important factor. We have different physical properties of rock materials, which can be classed as color, The color of rock will depend upon what kind of mineral that rock has. Then anisotropy, do we have all the constituent minerals present in that rock in random way, or they are having some preferred orientation leading to development of isotropic and anisotropic fabric. You can see this example of two rocks. The first one is having isotropic fabric, while the second one is having layering. That's why anisotropic fabric. The rock material which we are using, they may come from igneous rock, they may come from non-foliated metamorphic rocks, sedimentary rocks. These are all show isotropic fabric. But if you are getting samples from layered sedimentary rocks and foliated metamorphic rocks, then the chances of having an isotropic fabric will be more. The most important property of rocks to be used as a construction material is hardness. Hardness is another important physical property which is defined as resistance to indentation or resistance to abrasion. The hardness will depend upon the mineral component of a rock. If you have a monomineralic rock, it will have hardness same all through the rocks, but if you have polymineralic rock, it will have average value of hardness. We can measure the hardness in two different ways, in terms of absolute hardness as well as in terms of relative hardness. We usually measure the hardness of rocks as well as of mineral using Mohs scale, where we have relative hardness and which varies from 1 to 10, starting from talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum and diamond as minerals given different numerical values for their hardness. We have Vickers hardness scale, that is an absolute hardness scale that can vary from any value less than 10 to more than 10,000, as you can see from the table. Another important physical property is density of rock, which again will depend upon the mineral composition of the rocks. We have different minerals having different densities, and depending upon what kind of minerals with particular density level are present in a rock. So we can have rocks with low density minerals, medium density minerals and high density minerals. The density of commonly found rocks which are used in construction industry, they vary from 2.6 to 2.8. The dry densities of commonly found rocks and other construction material can be seen from the table, and it all depends that what are the mineral composition or the mineral content. Another important property is porosity of a rock, that is how much water it can absorb. It all depends again depending upon what kind of rock it is. If it is igneous rocks and metamorphic rocks, then porosities they are very low or almost negligible. But if we have sedimentary rocks, then the porosities may be high, which may vary from less than 5% to more than 25 or 30%. Related to the porosity, we have another parameter, that is permeability, which is related to the interconnection of pores. So you have porosity because of pores, and if all these pores they are interconnected, they constitute permeability. So permeability again varies from rock to rock. The rocks which are porous, they can have permeabilities less than 10 to the power 9 meter per second to more than 10 to the power 5 meter per second. You can refer to the table in the module to see the average values of different rocks in terms of their laboratory and field permeability. When we are using rock material for construction, we have to ensure its durability. Durability is defined as resistance to natural deterioration of rocks, because all our structures they are exposed to the atmosphere, so they will be subjected to vagaries of weathering, and hence durability is important. We can use a test to assess the rock's durability, and that test is known as slag durability test. Nowadays, because of atmospheric pollution in urban areas, we have lot of acidic rain, so we have to ensure that we are not going to use those rocks which can easily be dissolved in acidic environment. Rocks have got some thermal properties. Rocks are in general bad conductor of heat, but still they can conduct heat at a very slow pace depending upon what mineral composition our rock is having. The conductivity is important because the building which are using rock material, they will become hot and cold depending upon the outer temperature of our weather system. Then the most important property of rock material is its strength, because whenever we are using the rock material, they will be subjected to loading by different elements of buildings. So the strength can be compressive, strength can be shear strength, strength can be tensile strength. In most of the cases, rocks are used for their compressive strength. It is rare to have rocks subjected to tensile strength and when we use rock as a rock material. Sometimes rocks are subjected to shear strength as well as flexural strength. We can measure these strength using different instruments as an unconfined compressive strength and confined compressive strength using UCS machine and triaxial testing machines. The strength, uniaxial compressive strength as well as triaxial compressive strengths can be related to the density also. Rocks which are below the ground surface, they are subjected to loading from all the sides. So that's why triaxial strength is also important. For a faster test of strength of the rocks, we can use an instrument which measures the point load strength test, where we can have a small sample and we can test it in very short time using point load strength tester. Apart from this, we have some hammer designed on the basis of rebound from the surface of the rock, and we call them Schmidt hammer strength. Depending upon the different level of rebound, we can relate that rebound values to the unconfined compressive strength of the rock. You can see this is the Schmidt hammer which can be used for working out the rebound strength. Now we can have a very simple instrument which is a very important ready instrument with the geologists, that is geological hammer, which used to have 800 to 1 kg of weight and has one side blunt and other side tapering hammer head. The ease of breaking of rock by using that hammer can also give you an indirect strength of the rock. If you are not able to break the rock by firm hammering, that means the rock is having a strength more than 150 MPa. But if the rocks can be easily broken, then means that the rock has got a strength less than 5 MPa. Now rocks are sometimes subjected to shear strength, where we are using rock as a beam. So for that, again we have test for measuring the shear strength of the rocks, and the most important test is shear box test. Rocks are rarely subjected to tensile strength when we use them into the building. So this test is not very important, but still we normally use an indirect test for measuring the tensile strength of the rock. Rocks are subjected to shearing forces in buildings if it is being used in column or in beam. For that working out shearing strength, we have test, ring or punch shear test, or we can use shear box to work out the shearing strength of the rocks. Rocks are rarely subjected as a rock material to the tensile stresses, but we can measure the tensile strength of a rock by an indirect test which is called as Brazilian test. Flexural strength is an important parameter of rocks when we are using rock as a slab and rock as a beam. There flexural stresses are present, hence flexural strength is important, and for that we have a formula which is being given in the text to measure the flexural strength. Rocks are having some elastic properties, that is, they resist deformation. So the level of resistance to deformation can be measured as modulus of elasticity and Poisson's ratio. This can be done by getting data from different stress level and measuring the strain, and by plotting on a graph, stress strain graph. From there we can have different modulus ratio and Young modulus. So elasticity is important, but in building stones, it is we don't have that much of load where elasticity of rock is tested. But if you are using the rocks as a rock mass, their elastic properties becomes important. Now, depending upon its different uses, we are having some special properties of rocks. For example, for aesthetic uses, when we use rocks for aesthetic purpose, then we need softness. Softness is a very important factor because we have to carve out different features into the rock. So softness is an important factor. Now, what building stones we are going to use, it will all depend that which rock is available to nearby areas. So its availability is important, its workability is important, that how easily you can work with these rocks in terms of breaking, cutting, chiseling and dressing. And then of course, durability is very important because when you are using building stones in some part of your building, you want it to last for a longer time. Then we have building and dimension stones, which we are using as a part of walls and as part of roofing material, or as part of bridge piers, or as part of rock dams, as part of retaining wall, etc. So there, mineral composition becomes important because that controls the strength. Structure which is present in the rock in form of lamination and foliation, that is important because their presence will change the strength parameters of rocks according to the orientation of those layers. Then texture is important because texture controls the interlocking of constituent minerals. More interlocking is there, higher will be the strength of the rock. Less interlocking means less strength of the rock. So in that way, the sedimentary rocks are somewhat weaker as compared to metamorphic and igneous rocks. Now sometimes we are using rocks as a flooring material. So there, abrasion becomes very important because once we use rock as a flooring material and people are moving over them, then the rocks are subjected to abrasion. So before going for deciding any rock, we go for some abrasion test, that is, for example, a Dory's test, which is explained later. Our rocks should also be frost resistance to the frost and fire because we don't want any rocks which can aid frosting. All porous rocks will add frosting, but non-porous rock will be free from the problem of frosting. As far as fire resistance is concerned, it has been found that rocks which are monomineralic, they are faring better in terms of fire as compared to the rocks which are polymineralic. The most important use of rocks nowadays is in concrete, where we are using rocks as aggregate. A concrete has got four important parts, that is aggregate, which constitute around 70 to 75% of concrete, cement, which is present as a binding material, water, which is going to be used for hydration and chemical reactions, and some additives to increase the workability and durability of the concrete. Aggregates which we are using can be coarse aggregate as well as fine aggregate. So for example, bigger rock pieces, they are coarse aggregate, and sand which we are using, that is fine aggregate. So we have different physical properties to be confirmed for rocks to be used as aggregate. For example, the size of aggregate, gradation of aggregate, shape of aggregate, surface texture of aggregate, coatings on the surface of the aggregate, etc. So these are the important physical properties which should be satisfied. Then we have some mechanical properties of aggregates, which include hardness, toughness, crushing strength, binding properties, hydrophobic properties, and chemical properties. One of the very important chemical properties is alkali aggregate reaction, which is a problem with the concrete when excessive water can dissolve some alkalis, free alkalis from the rocks as well as from the fine aggregates and forms alkaline solution which reacts with the free silica and forms silica gel. These silica gels try to move up through micro cracks and result into the cracking of the concrete. Now, a very common use of rock as a material is as road metal. We are using rocks for construction of roads. We have different layers in the roads. At the bottommost, we have earth or soil over which we have different layers of rocks, which are load-bearing rocks, which are binder rocks, which are void-filling rocks, and at the top we have wearing cores. So we have different rocks at different levels. The most important parameter of road metal is that it should be strong enough, it should have high impact strength, it should have high attrition strength, because once vehicles move over the road, the aggregate, they vibrate below the asphalt and they hit each other. So we need to have a strong rock which has low attrition value. Then we have a very important property, that is resistance to abrasion, because resistance to abrasion means that how fast your rocks they are going to abrade under the influence of rubbing influence of tires. For this we have a different test using different instruments. For example, we have a test which is called as Devil's test for measuring the attrition. We have toughness test for measuring the impact strength. We have stripping test for measuring the binding property of tar or asphalt with the rocks which we are using as a road metal. So these tests are very important tests for the rock material to be used for road metal. Then we are using rocks, you must have seen along the railway tracks, you have a lot of rocks termed as rail ballast. Mostly we are using crushed rocks which are angular and which are equidimensional. These rail ballast, they are subjected again due to vibration, because once train moves over the rails, the movement of train is transferred below through the sleepers into the rail ballast, and they subject to abrade each other. While abrading, they will create powder, and this powder with moisture, they will cement those aggregates, the rail ballast. We don't want the cementing of rail ballast because we need to provide freedom for vibration to the railway tracks. So that's why rail ballast should be used those which have very high resistance to abrasion. That is an important factor. Then we are using rocks as an energy dissipator along the coastal areas where we have to protect coast from erosion, along the river banks where again we have to protect the shifting of the rivers or erosion by rivers. We can use rocks along the earth dams to protect it from erosion. We use rock blocks to pave the abutments of bridges. Main purpose of this energy dissipator is that it has to minimize the wave energy so that erosion is restricted. The rocks which are used in this for this purpose, they are called as riprap. We can also use concrete tripods for the same purpose. So that's all about the rock as a construction material. Another important aspect of rocks is when we are using rock as a site rocks. That is, that rocks, they are present at its original place, and there we are making some building over it, some dam over it, some road over it, some railway track over it, or sometimes we are making those structures which are inside the rocks. For example, tunnels, for example, bunkers, for example, underground powerhouses, for example, any structure for strategic storage. So here, the properties of rocks will be used in such a way that whatever present in the rocks, all these things will be taken into consideration. So we call them to be the site rocks. Now, site rocks have joints into them. They have some weathering state. They may have some water. So all these clubbed together, we call them rock mass. Now, if we are working in some site having rock mass, then we have to take into consideration the three important parameters. That is, we have to divide the whole rock mass into groups with similar behavior or quality. We have to identify the key factors each rock mass class is going to be present for ready reference, as well as we have to generate some quantitative data and guidelines for engineering design. The rocks which are present in natural condition, they also have some stored stresses. These stored stresses, they may come into play when we load rock or we are going to unload rock. In both the cases, these stored stresses can play a very important role. If you can see here, we have rocks, two different rocks with different kinds of discontinuity surfaces and different weathering state. We are not going into the details of site rock classification at this stage, but I'll just like to mention the important engineering classification of rocks which have been given from time to time. The first one, rock load theory, which we have discussed in module 1, which was given by Carl Terzaghi in 1946. This is important for tunneling and steel support into the tunnels. We have stand-up time classification given by Laufer in 1958. We have new Austrian tunneling method given by Pescher et al. In 1964. We have rock quality resignation, a very important classification given by Deere et al. In 1967. We have rock structure rating concept given by Wickham et al. In 1972. We have rock mass rating system, again a very important, very versatile engineering classification of rock given by Binyowski in 1973. Then equally good classification we have, that is rock mass quality or Q system given by Barton et al. From Norway in 1974. Then we have lot of extensions of RMR system as well as Q systems for different purposes. For example, Kestin has used it for excavability and tunneling. Then we have other important classifications: strength size, basic geotechnical description, unified classification, rock mass jointing, and slope stability property. So these were the important engineering classification of rock mass. Now we can summarize in nutshell that rocks which we are using as a building stone, we are using as framework blocks, we are using rocks for making concrete as aggregate, we are using rock for road construction, for rail ballast, etc., etc. And all these need some specific properties to be present in the rocks. Apart from this, we have some uses of rocks in rocky terrains where we are using rock as a site rock. There, rock mass property becomes very important. So may it be rock material, may it be rock mass, it has to satisfy some important physical, mechanical, chemical, and stress related properties. That's all for the module 2.